Now, why a person would take an amplitude of the moon at moonrise or moonset, I don't know. That sounds like a massive pain because not only do you have to line it up to be, well, you realistically can't even get it on the celestial horizon. That would be too difficult. So you'd kind of have to do it on the visible horizon. And you'd have to, first of all, calculate when moonrise or moonset is. You'd have to then be out there ready and get a good bearing of the moon. It might not even be on its upper limb. It might be on the lower limb, or it might be on the lower limb or the upper limb. You don't know because of the phase of the moon. It's just like you're putting a lot of extra work on yourself for a correction that you could do on any other body at any other time. If anything, you could just take an azimuth of the moon later in the day. That would be a lot easier. But if you did want to, or if more realistically you were given a question on how to get the amplitude of the moon, you would do everything like we just did normally, where you get the declination of the moon, you compare it to the latitude using the formula, and then you apply that either away from east or away from west based on if it was sunset or sunrise. But then when you get to the correction table here, you can see in this case, it instructs you that for the moon, you're going to take whatever your correction you found, you're going to now divide it by 2, so you're going to take half of the correction, and you apply it towards the elevated pole. So, whereas for the sun, or for a planet, or for whatever you might be measuring, I said that you would take, if it was in the north, you would apply that correction to the south. For the moon, you're doing the opposite. If it's in the north, you're applying that correction to the north, and you're dividing that correction by 2. And you make sure you're applying it to the observed amplitude or the observed bearing, not the calculated bearing. There are lots of ways to get this wrong. There's a lot of opportunities to get confused because this is something you do so rarely, but you have to remember all of those stipulations. So half of the correction in the opposite direction that you would apply the correction for any other body, and onto the observed bearing, not the calculated bearing. Got it?